Right, lads, how are we getting on? So, steal away from the PlayStation Xbox for a while. Just run over a few things that we've been looking at before we left up, and we'll move on to two new things that we're going to look at today. First things first, anyway, just a quick run through calculating the equation line containing the point with a slope of 3. So this one is basic enough because we have our point and we have our slope. Our point is 2, 1. And our slope is 3, so all we have to do then is use our equation of the line formula, y minus y1 equals m times x minus x1. So first things first anyway, we use our steps, label your point x1 and y1. So that's the y1 here and the x1 here. The y and x are important. That's not y1 and x1, these are important though because that's going to come into the new bit we're going to learn today. So that's y minus 1 is equal to 3 times x minus 2. That's y minus 1 is equal to 3x minus 6 is equal to 3x minus y minus 6 plus 1 as the y comes over and the minus 1 comes over, which is equal to 3x minus y minus 5. So as I told you above here, this y and this x is important for the next bit. So if we were to look at that, that is this line here. And as we can clearly see, the point 2, 1 is on that line because we included it in our formula up there. And that is very important for the next bit we're going to do. Because what we're going to look at today then is this bit here. 2 seconds. Yeah. So, this is slightly different to the thing we just looked at last. Why? Because it's generally the opposite. What happens here is they're giving us the point 4, 1 and they want us to check, is it on the equation of the line? So here we have x plus y minus 5 is equal to 0. Now, 4 and 1 are no longer x1 and y1 in this equation. This is your x value and this is your y value. So what we want to see is, we want this equation to balance to 0. Because if this equation balances to 0, that means the point 4, 1 is on our equation of the line. So as always, this is now x and this is now y. Not x1 and y1, this is x and this is y. This is the only part of the question on coordinate geometry where this changes from x1, y1. The reason for that is we're not using a formula. We have our equation of the line. We want to check when we sub in these values, does it give us 0? So for example, instead of x plus y minus 5 is equal to 0, we can check 4 plus 1 minus 5 is equal to 0. 4 plus 1 is 5. 5 minus 5 is equal to 0. 0 is equal to 0. Which makes sense because if you come over and look at our line over here, we were asked to look at the point 4, 1. There's 4, there's 1, and we can clearly see it's on the line. The reason why this is handy is if, for example, take the point 2, 2. Now, we can see that 2, 2 is not on our line. If you sub in the point 2, 2, for example, 2, 2 would be 2 plus 2 minus 5. 2 plus 2 is 4 minus 5 is minus 1. Minus 1 is not equal to 0, which makes sense because the point 2, 2 isn't on our line. The point you sub in must equal on the left hand side as to what it's on the right hand side. By the way, it's not always going to be 0 on the right. With that in mind, the next little bit we're going to look at is the last little bit which we haven't looked at, which is graphing lines. So, we came across graphing the equation of the line earlier on when we had this formula, y equals mx plus c. In our logbooks, there's two formulas for the equation of the line. The first formula is the y minus y1 when we're trying to create the equation of the line. The second formula, which is the one up here on the right, this formula we use on two occasions. One, when we're given the equation of the line and we're looking for the slope, which is, as you all know, m. And 2, when we're asked to graph the equation of the line. So take, for example, the following. X plus y minus 5 is equal to 0. In this equation, we now must make this, x plus y minus 5 equal to 0, look like y is equal to mx plus c. So, for this to work, y must be on the left and it must be singular. The x value must be brought over to the right because it's going to tell us the slope. And C over here must also, which is the number on its own, must also be on the right hand side of the equals. And this tells us where it cuts the y-axis. We've looked at this before in functions when we were graphing linear equations. So, first things first, y is on the left, so that's perfect. But x is on the left, and minus 5 is on the left, and we know these need to be on the right. So that's y is equal to minus 1x plus 5. We can now see that minus 1 is the number in front of x, which tells us the slope. And 5 is on the right hand side, that tells us where it's going to cut the y-axis. So with this in mind, first thing we're going to do is we go to our y-axis and we look for 5. And we can clearly see that 5 is there. Now, as you might remember from when we were doing functions, a slope of minus 1 means we fall 1 and we run 1. Fall 1 and run 1 means fall minus 1, run 1, there's your second point, and there's our line out of it. Right, anything else from today that we haven't looked at, I advise you to go back and look at, but these are the two things I want you to focus on today. It's checking if a point is on a line and graphing the equation of a line.